Okay, friends, ready? We're going to do this quick lesson because it's a complete review. We started it in class today. Okay, so we started with, we actually didn't start with this. We started with 4x to the fourth minus 16x squared, which we realized that we could make 4x squared times x squared minus 4. And that's partially factored, but it's not completely factored because we did our first step, GCF, we did that, but we need to keep looking. And so this should be very kind of familiar to you. This is something we call the difference of two squares. Okay, back in the day we used to say the difference of two perfect squares, but perfect squares, it's kind of redundant. Okay, so it's the difference of two squares. So what this actually means is, like, what is our b? Well, our b is 0, right? Our b is 0. So we have to look for factors of -4 that add to be 0. Factors of -4 that add to be 0 are +2 and -2. Okay, those are factors of -4 that add to be 0. So if I was to factor this, well, I have x minus 2 and x plus 2. And now you should be saying, oh, aha, I remember. Okay, so you have two binomials. One of them has a positive and one of them has a negative. And if you were to if you were to check this by foiling, you did the first, x squared, outer plus 2x, inner minus 2x, and lo and behold, these guys actually, yes, they cancel each other out. This goes to 0 and then minus 4. So all together we have x squared minus 4, and this is called the difference of two squares. So when you're given something like this, 4x to the fourth minus 16x squared, and you start with taking out your GCF, which is something that you have to do, you have to say again, can I factor again? Can I keep going? Can I keep going? And you have to know, yes, I can keep going because this is something we call the difference of squares. So I can actually take this quadratic binomial. I know you're used to quadratic trinomials, but we have this quadratic binomial. It's called the difference of two squares, and I can keep factoring this. So ultimately, if I want to factor completely, I have to keep going. So I have to look. This is my question. Can I keep going? All right. And this is your final answer. Remember, when we're factoring, I'm actually going to put just an arrow there because there's really no equals to signs, right? When we're factoring, we're not solving anything. We are just factoring. So this, again, this is what we kind of started with in class. This is our expanded form. And this is our factored form, factored completely. Okay, again, factored completely. Right? And that's something that you have to look for after you take out your GCF, is that difference of two squares. You also want to do that, well, what if I had 2x squared plus, I'm going to say 20x plus 50. All right, well, you automatically know, definitely that the GCF is a 2. So I then take that out. Okay, which is, bad language for factoring the 2 out. But then I have to look at this trinomial. And we did this in class. This is something we call a perfect square trinomial, which means that I can factor it into 2 of the same factors. So now, and of course, I can always simplify this by writing 2 times x plus 5, the quantity squared. Now and only now am I done. This is only the first step in factoring here. Okay? Your final step is to say to yourself, can I factor what's inside the parentheses? Okay? Can I keep going? And if I can factor what's inside the parentheses, I can't forget to keep my first factor, my GCF, in there, but then I have to keep going. You're going to practice this tonight. Okay? So you're going to look for your GCF. First step, GCF, right? Once you've done that, you want to say, can I keep going there? Do I have the difference of two squares, right, that factor into almost the same looking binomial, but one is a negative and one is a positive, so we can get rid of that center term if I'm going back up here. That's why one has to be positive and negative, all right? Hopefully this is all very, very, very familiar to you, my friends. Have a good night.